So I'm sorry about the heater going in the background. So what I'm trying to do here is I'm trying to fit y equals AB. I mean, you could use the base E. I'll tend to use this plus some constant. It's a transformed function, right? So I see that the room temperature is 75. So in the long run, so as x goes out to infinity, or as t goes out into infinity, this turkey is going to cool to 75. So that tells me I have y equals a times b to the x root of the t plus 75. So that's that horizontal asymptote, right? This has been shifted up 75. Now, they gave me a couple other points. They told me at time 0, this turkey is 185 degrees. So let's see what that does for me. So 185 degrees equals a times b to the 0 plus 75. So if I subtract 75, I get 110. And b to the 0 is 1. So a is 110. So I'm going to come over here and write this. I'm going to write y equals 110 times b to the x plus 75. Okay. Now I haven't used, so then it says, let's see. If the temperature of the turkey is, here, red I need, 175 after 30 minutes, right? I'm changing the half an hour to 30 minutes because everything else is in minutes. So I've got 30 is 147. If I substitute this in, I'll be able to find out what B is. So 147 equals 110 times B to the 30 plus 75. So I'm going to subtract 75 and I'm going to get, oh my, I should be able to do that in my head. It's been rough this week. 175 minus 75, or 147 minus 75, I'm getting 72 equals 110 times b to the 30th. And then I'm going to divide by 110. So I'm getting b to the 30th. b to the 30th equals 0.6545. And I got a bunch of other decimal places. Now, this is a power function because it's a base raised to a power, not an exponential function. The way, if this were b squared, wouldn't I just take the square root of it? Well, so what I'm going to do now is I'm going to take the 30th root of it. And what I'll usually do when I have to take the 30th root, sure, your calculators have those extra keys, but I just remember that the 30th root is the same thing as raising a number to the 1 over 30 power. It's a lot less key pushing. So I've got this on my calculator still, so I'm going to raise it to the 1 divided by 30. No, I just typed 7 divided by 30. Just a minute here. 1. So I'm getting B is equal to 0.98597. Since I'm trying to keep my open math happy, I'm going to go with more decimal places. That is an exponential decay equation because the base is less than 1, right? So then that leaves me this equation. I have y equals 110 times 0.98597 to the t or the x plus 75. So let me clean some stuff up so I can finish this up. So to answer question A, they want us to find the temperature after 45 minutes. So that means t or x is 45. So 110 times 0.98597 to the 45 plus 75. And this is just typing it in. I mean, if you got a TI-80 calculator, or you can use Google Calculator. If you're going to use your phone, here's what I would do with your phone. I would raise this. I would take this, type in that number if it's not already on your screen, and raise it to the 45 power first. So mine's still on my screen, so I'm going to raise that to the 45th power. That gives me 110 times 0.52955 with a bunch of other decimal places. Then I'm going to times that answer, multiply that answer by 110. Got to follow order of operations. I'm getting 58.251, and then I'm going to add 75 to that, and let's see if that gives the 133. Yeah, I got 133.251. Yep, so that works. Okay, maybe you're rounding too much. I don't know. That's let your calculator carry decimal places. Don't round too soon if that's what you're doing. Okay. Now for part B, we want to see how long before it cools. So let me get rid of some of this ink. So Y is, on my formula, Y is 100 degrees. So 100 equals 110 times 0.9857. 0.58, oh boy, 0.98597. Yeah, I don't want to mess up and get that wrong, huh? I won't tell you how many times I have before. Hitting that wrong button. 0.98597 to the x plus 75. So now I have to solve that for, for x, right? So I guess I'm going to subtract 75, which is 25. And then I'm going to divide 25 by 110. So 25 divided by 110. So I'm getting just a minute here. 0.22727. Oh, it's a bunch of repeated decimals. That's cool. So I could write that as a fraction. Oh, yeah, I could write it as a fraction. That's silly. Equals 0.98597 to the x power. And now that's an exponential equation. Yeah, I could do the log of both sides. I could also rewrite this as a logarithm, right? If you were in my physical classroom, I would have been doing this right along. But so the base is log 0.98597 of 0.227273 equals x. And I'm hoping you've done enough of this now. This is just a change of base formula, right? We'll do the log of this divided by the log of that. So I got most of these on my calculator. So I'm going to do log. Let's see. I'm going to do log. Where's my log button? Log. I'm using a different calculator. So log of that answer divided by the log of 0.98597, and I'm getting 104.86. Ooh, not the right answer. Ooh, give me a minute. All right, I feel silly now. I have a right answer. So I got on my calculator, I got x equals, I'm going to repeat because I never wrote it down. I got panicky because I didn't agree. I got 104.876. 876. But that's minutes. And what are they looking for? They're looking for hours. So if I divide that by 60, I get the right answer. Okay, so units matter. If you need more help, give a yell. What's happening here?